So here we are on the eve of the launch of Raspberry Pi. We're in Nuremberg and it's the Embedded World Show. And I'm privileged to have sitting next to me Pete Lomas. Pete Lomas is a trustee of the Raspberry Pi Foundation, has an active part in the development of the board. And I would like to take this opportunity to ask you a few questions of your involvement. Sure. What's been your role in this whole, the evolution of this incredible project?
Well, it all started out for me as a chance conversation, actually walking across Hyde Park with some of the other trustees. And we didn't know we were going to be trustees of a foundation called Raspberry Pi at that point. We were just talking about how kids didn't play with electronics anymore. You know, the Spectrums and the Ataris and all the things that we grew up, it's all disappeared and really been replaced by Xboxes and now iPads and iPhones and all that sort of technology. And what it takes away is the ability to get inside there and tinker. And we think that that's important because that's where you develop an interest in the product. You think, what if, maybe just, can I do this, can I try that? And it's that sort of spark of imagination. I think the thing that got me started, I mean, I don't really want to talk about age, but people might remember PDP-8s. That was my first computer, and I sort of worked on that, and I realised if you can imagine how to do something, then you can get the computer to do it. You can create any virtual thing that you like inside a computer. And it's that spark of realisation and that spark of innovation that we want to try and put back in kids today in terms of computing. Not just how to make something look pretty on the screen, not how just to play a game, but how to get involved, dig in there and actually create something.
So it's encouraging this, it's sort of almost like hacking behaviour, sort of engineering behaviour, and making it an open board. So that's the behaviour you're trying to.
Yes, I think hacking has been given a bad press. I mean, my understanding of hacking is the messing, building, bodging, just trying to get something to go. Because I'm sure that a lot of the great developments, certainly in electronics, have come from people asking the question, what if? I wonder whether we could just do this. I wonder just whether that's possible. And then taking that as an idea and trying to take it forward. And I think the idea of Raspberry Pi, both at a software and a programming level and also at a hardware tinkering level, is to give kids the opportunity to do that on something that isn't going to break the bank if you do break it.
So can you tell us a little bit about how the boards evolved from those very early days then?
Well, we started off with an idea and we really didn't have a chip to really focus on. And really that was the work that Eben had done in actually focusing in on one of the Broadcom range of chips that we could use. Now, the original design comes from a big development board that was actually developed by Broadcom.
Yeah.
That was refined by some highly talented people at Broadcom to make what is, if you like, the alpha board, which you have seen some pictures of out on the web. And then really my challenge was to take all that good stuff and get it onto a credit card. Now, you know, I looked around in my wallet for as long as I could to try and find the biggest credit card because I wanted as much real estate as possible, but you know, the reality is they're all the same size. So I just had to accept that that was the size of the board, that was going to be challenge number one. Challenge number two really came from the fact, well, the Broadcom chip is a mobile telephone style chip. It's very small, it's ball to ball, it's 0.65 of a millimetre, which is by anybody's estimation is very tight, which meant that we were going to potentially need a high technology board to mount this on.
Yeah.
But then when you look at the board, there's not really a lot else. There's the Broadcom chip, there's a support chip to do our USBs and Ethernet. There is very little else other than a few power supplies and a load of connectors, and that's what allows us to bring it in at the price point that we can get. But it does then bring the challenge of making the actual fabric of the PCB, like this one, actually meet that cost point.
So you had to find that right balance between, you know, routing out of the device and the cost of the board, the final cost of the board.
Well, that's right. I mean, the individual boards themselves have to be, you know, the order of a couple of dollars each. So we couldn't go to some high technology board that may have blind and buried wires. But what we did is we talked to some of our fairly talented PCB manufacturers, and we had a lot of conversations with them, and they said, well, you know, well, what we need is we need a ground plane underneath the device, but I don't want to have to connect to it by wires that go all the way through the board.
Right.
And they said, well, no, you could possibly just put blind wires just on the top side of the board, and we can drill all the holes in the board in one hit and then go back and just partially drill the holes that only go through the first two layers of the board, and then we can use our normal processes, and that won't add much to the cost of the board. And we thought, well, I've not actually seen that done anywhere before, but we'll give it a go. And it works, and it worked really well for this board. But we only need the technology just inside the borders of the Broadcom chip. Everywhere else, it's fairly standard technology.
So the board is not launched yet, it's launching tomorrow. There's been a huge amount of activity on the web and in social media and all over the place. Has that surprised you, just the amount of sheer talk about this project that's out there already? Something that's not even launched?
To be honest with you, I'm absolutely staggered at the interest. What started off as a relatively small project. I mean, I had my head down looking at the artwork, trying to get the final thing sorting the last bits of the bills of materials, supervising the build of the prototypes. And I sort of, I want to say I didn't pay much attention to the web. I sort of would look occasionally and I'd read a few things that people were saying about it. It really wasn't until I just, rather than go to the site, I just Googled Raspberry Pi and I thought, oh yeah, 1.6 million hits. Wow, that's quite a lot. And then I looked at it again and it's 16.7 million. I thought, wow, we really have made an impact here. And I think if we can now galvanise that impact that we've made and actually get it to do what we want, which is to get children inspired in computing and electronics that connects to that computing, then it's going to be absolutely brilliant. And I'm really looking forward to what is now, I think, going to be a roller coaster.
Well, Element 14 is very proud and privileged, I think, to be part of this project. So we are looking forward with bated breath to the launch tomorrow. Thanks for joining us and having this conversation with us. We really appreciate it.
Okay, you're welcome.